So, hi everyone. My name is Toma Puljak, and today I'll show you that onboarding developers like Uber or Stripe is simpler than you think, and why should we even strive to have a similar onboarding experience to theirs at our companies. So, a bit about myself. I'm 22. I'm a software developer at Daytona, where I'm part of the core company team. I've been with Daytona, or with our core company Code Anywhere, for about 4 years now. 2 lines about Daytona. Daytona is a startup that aims to empower developers to focus truly on what matters, and that's actually developing and not spending time on environment or toolchain configuration. We offer SaaS and self-hosted development environments and aim to make the entire DevOps lifecycle as efficient as possible, no matter where you want to run these environments. I'll talk a lot about developer velocity in this talk as well. And if you want the official definition, it's a metric that helps estimate how much work a software development team can complete within a specific period of time, or just simply how fast is the developer completing tasks. And as you may imagine, a big part in calculating developer velocity is the actual onboarding process, because every time you want to contribute to a project, you have to onboard yourself to the required environment, the required tools, and so on. So how does the classic approach to onboarding look like, and what is our reality currently? The reality is we have to check out a branch or clone a repository, and then we need to set up the required environment by downloading some tools, dependencies, or libraries, wait for them to build, compile the entire project, and then wait for all the tests to run before we can actually start coding. And this train of thought is long enough, but actually running through this entire process can take from tens of minutes to hours or even days if you're just onboarding to a company and don't have the required tech stack available. And this, of course, multiplies across projects as well, because for each project that you work on, no matter if it's a company project or a new open source project, you need to go through this exact same process every single time. Or just simply, if you're working on multiple branches at the same time, each branch may have a different configuration required, and again, you need to onboard yourself, and you're losing productivity along the way. And again, this multiplies across all your company teams, and this slide represents inefficiency within the company, because all of these images here display just how inefficient the whole onboarding process is. And what is the dream? What's the dream onboarding scenario? The dream is to start coding as soon as possible in the onboarding process. The dream is to be as efficient as possible and not waste time on these unnecessary steps I talked about before. And tech developed internally at Uber or Stripe basically does just that. It allows you to be part of the dream. Uber published an article last year talking about their source code architecture in 2017. And in 2017, they had their source code spread amongst thousands of repositories, more than 4,000 services, more than 10 programming languages. And you can imagine how much of a nightmare it is to maintain libraries, dependencies across all of these repositories. So in 2017, they moved to a monorepo source code architecture, and they found new challenges with this kind of approach. The challenge was that now developers locally need to download gigabytes of code, run tests, and build all those gigabytes of code before starting coding. And they state in the article that sometimes just checking out a different branch could take even hours before you can actually start coding. So they created a solution called devpod. And devpod is their internal development tool that allows developers to start coding basically instantly. And how does it all work? Well, what does a developer need to do from Uber to start coding? They just need to click a button that will provision a devpod instance, and that devpod instance has everything you need to be able to run and start coding. It has artifacts built, it has the source code already cloned, and most importantly, the ID cache is already loaded. And I know I don't want to diss on IntelliJ too much here. I really love JetBrains IDs, but if I get the chance to never have to wait for any ID asset loads, I'll take that option any day of the week. And of course, devpods are tightly integrated with the developer's local IDE, as developers can choose VS Code or any JetBrains IDs, or if you're that guy, you can even use Vim via SSH. And talking about the architecture a little bit, you can see here that they use Kubernetes as the underlying orchestration platform. And that means, of course, that devpods are container-based. They also use, for the base for each devpod, they use their production image, their production runtime. This gives them a unified runtime from development to production. But they also expand upon the base container image with additional dev tooling, such as specific debuggers, bundlers, LSPs, and so on. And they call this specific images flavors. So, for example, you have Go flavors, ML flavors, web flavors, and so on. And there are two lessons to be learned here. One is because they use the production image as the base for all the dev pods, that means you have a unified runtime from development to production, which can eliminate those bugs occurring in production just because you have a different language version installed locally, for example. And the second lesson is because all of these images and all of these dev pods are tailored exactly to Uber projects, that means any developer inside the company can actually run projects and code inside the company no matter how long they've been there. Day 1 or day 1001, it's always the same process, clicking a button and starting coding. And also, I want you to notice that devpods are available everywhere in the world. Because remote development can have a latency drawback if you're very far geographically from the running code. They deploy devpods basically anywhere in the world, so all of their developers can have that local look and feel. And there's a similar story in Stripe as well. And Stripe decided to start small a couple of years ago when their team was quite smaller than they are today. Their problem was that their service mesh was so complex, developers couldn't test their code locally because they couldn't run the entire source code. So their solution at that time was to spin up a few EC2 instances that were long-lived, and they pre-configured the entire service mesh there. And then developers could just SSH into the environment and test out all their code on these beefy machines. And how did they agree upon which developer can use which machine? Well, they basically created a Slack channel for each of the EC2 instances. And you would write in Slack channel 2, for example, I want to use machine 2 for a couple of hours. Can I test my code there? If you didn't get a response in a couple of minutes, you're good to go, and you can test out your code, and you're done with it. And it's funny to think that this actually worked for a company like Stripe, but it did because their team was so small at the time. And now Stripe has a full dev productivity team whose aim is to solve these exact issues. And their solution is called DevBoxes. And DevBoxes are per branch ready-to-code development environments, also remote environments. I won't get into much detail how they got to where they are today, but they found that the biggest boosts to velocity and to improving onboarding were given by making the dev boxes previewable and as close to production as possible. By having so-called preview dev boxes where developers could instantly preview the running code, they eliminated all reviewing headaches as well. Because as a reviewer, what do you need to do to review an actual PR, for example? You have to commit your changes, you have to check it out locally, review what needs to be reviewed, and then you're done. With preview dev boxes, you can instantly jump into a dev box without disrupting your current workflow, review what needs to be reviewed, and then go back to your workflow without even having to commit the changes you're working on. And this goes to show that these kind of remote environments don't just influence coding directly, they also influence the entire DevOps pipeline. I think it's cool that Stripe puts such a large emphasis on collaboration as well, because when you have remote environments running in the cloud, you, as developers, can really easily collaborate on code running in these cloud environments. But not only that, cloud environments also allow non-technical people to be involved in the process much earlier. For example, PMs or designers can instantly preview changes that are running inside the environment, and that means developers get feedback much earlier in the process without even having to push your code. Now, without these features, for example, I, as a developer, need to push my code to a staging environment, wait for the review process, and then the review comes in. I have to do it again tomorrow, and so on and so on. With this kind of setup, it's instant feedback when you're actually developing. And taking a step back and seeing the entire DevOps lifecycle, you can see the DevOps lifecycle has coding, testing, deploying, production, testing, and releasing, and so on. And you'll notice that all of these steps above require some kind of environment to run. You have a building environment, testing environment, staging environment, production, and so on. And as I mentioned before, Stripe and Uber put such a large emphasis on keeping their coding or development environment as close to production because it eliminates all those local versus production bugs and configuration drift. But what if we can take this a step further and have the same environment running across the entire lifecycle? The exact same environment for coding, developing, building, testing, releasing, and so on. What if you, as a developer, are just onboarding to a company, you pushed your first line of code, and because it worked on your local environment, it's going to work in production as well, because the underlying architecture is the same. And that's where standardized development environment come in, or SDEs. And SDEs allow you to have a seamless experience across the entire DevOps lifecycle because they are standardized and made to be executed on each step of the way. And of course, SDEs can be SDEs without a standard that's being used. And at Uber, they chose Docker as their base for all their flavors. Sorry. And at Stripe, you have opinionated environments that have the service mesh pre-configured by someone that's configuring the initial environment. And I think the biggest or best standard that you can choose to implement in SDE is in-repo configuration. That means that your configuration of the environment is part of your source code. That means that for every commit inside the Git history, you have an environment ready to code no matter what's inside the repository. That means checking out legacy code and working on 5-year-old PRs is just a click of a button and not configuring some legacy libraries or legacy languages or whatever. And I think one of the best current standards is dev containers from Microsoft. And dev containers are an open source standard that not only allow you to define which kind of runtime database or any other service you need, you can also configure what your ID needs to have to be as efficient as possible. And here we can see a feature of dev containers called features, and it's basically a parallel to devpod flavors. For example, you can use the same production image as the base for your dev container, but you can expand upon it with features. For example, in this example above, I chose to change the Linux kernel user. You can also include additional debuggers, builders, or LSPs, or whatever you need to expand upon the base production image and include all required development tooling. Also, as I mentioned, dev containers allow you to include ID specification as well. Like in this example above, I included some VS Code specific configuration that developers inside the company need to be as efficient as possible. Imagine you're onboarding to a company and you need to go to your docs and look at the configuration JSON for your VS Code, or which extensions do you need to download to work with the source code of the company. Dev containers allow you to bundle it all inside your Git repository. And the beauty of this is that SDs are already here. You can have, you already have SaaS companies such as GitHub Codespaces and Gitpod allowing you to spin up SDs in the cloud with a configuration that's part of your source code. And with Daytona, you can actually self-host the entire solution. You can have your solution behind your company firewall. You can air-gap it. You can do whatever, and have your development environments running where your company infrastructure is already running. So, to sum up this short talk, how can we eliminate onboarding headaches and how can we boost developer velocity? Having a ready-to-code ephemeral SD is one of the biggest boosters to velocity and eliminates basically any onboarding headaches because you go from scratch to coding in just one click. ID integration further speeds up the entire process because you don't have to worry about extensions, configurations, and ID caches and so on. Collaboration and preview can influence the entire DevOps lifecycle, not just coding. And security becomes a given because you can self-host the solution, you can throw it under your company firewall, and the beauty is that the code never has to touch the developer's local machine. It's all running in the cloud. And also the local and production gap can be bridged or basically be as close as possible. Thank you so much. I don't have time anymore, so thank you. I hope you implement SDs in your company as well.